Okay, here we go. A little bit of everything here, right? It's a great question. All the great questions cause the most internal strife and mental anguish to students, but that's what makes them great. That's kind of a joke. Nobody really laughed at that. But here we go. All right, so we've got a product. Now, nobody wants to actually foil all of this mess, right? We want to make it simpler before we multiply. So we factor, right? Up top, hopefully you notice, this is the sum of cubes. And remember when we talked about how to factor the sum of cubes, take each one of these cubes and write it as a power. So for example, like I said before, if this was an 8, I would want to rewrite that as 2 cubed. Because the format for factoring the sum and difference of cubes is written in terms of that A and B stuff. Well, 1 is 1 cubed. So when I go to write this in its factored form, I'm going to use x wherever there's an A in that format, and I'm going to use 1 wherever there's a B in that format. So the factored form of this first part, x plus 1, x squared minus x times 1 is 1x. I'm just going to write x, and b squared is positive 1. Now on the bottom of this fraction, x squared minus x minus 6, a quadratic trinomial. Can I find two numbers that multiply to be negative 6 and add to be negative 1? I bet I can. Negative 3 and positive 2. And then over here, a quadratic trinomial, x plus 5 and x plus 1. Why the 5 and the 1? Because 5, I had them switched, right? The product has to be 6, the sum has to be 5. I had a product of 5 and a sum of 6 today. Did you guys recognize that? You probably did. You probably did. On the bottom, a quadratic trinomial. Are there two numbers that multiply to be positive 1 and add to be negative 1? No. No, there aren't. You can try, it won't work. Okay? You're like, negative 1 and negative 1. No. Negative 1 plus negative 1 is negative 2, not negative 1. Okay, fine. Negative 1 and positive 2. Not true, not true. It won't work. Take my word for it. And you'll remember I said before, with binomials, if you can't factor it, just put parentheses around it. Just do that. It helps to visualize some of these things. Such as the fact that this doesn't factor, and it is also in the numerator. So when now we're multiplying, now we've factored everything as best as we think we can, we start looking for common factors within each fraction and common factors on these diagonals that we can cross-cancel during this multiplication. Okay? This is the same as this. They will cancel. It's the only thing in the bottom over here, and it's being multiplied over here. We've had that theme all day long, right? If it's being multiplied, you have those parentheses butting up next to each other. On the diagonal, I have an x plus 2 here that's being multiplied, and I have an x plus 2 over here that's being multiplied. Within each fraction, nothing I can do here. This is different from this. This has a minus, this has a plus. I'm not going to be able to turn that into just a positive by taking that negative out. We've gone through that already. Okay? So now I just multiply straight across. I can write my final answer in factored form. Okay? This is okay. If you want to FOIL it, you can do that too. But the stuff that we get into later on, like finding asymptotes and holes in the graph and things like that, it's best to keep things in factored form most of the time. Okay? So I think at this point, we can put a box around that. Questions? So, factor first, always factor, cancel within a fraction, cancel across when you're doing multiplication. Now, I'm not going to do an example of this because we won't have enough time to do a bunch, but if this is a division symbol, how does this problem change? What do? We are dividing, and when you are dividing a fraction, what do? You multiply by the reciprocal. So even though this is a multiplication problem, if for some reason, and not for some reason, when you do problems like this with a division symbol, the first thing you should do is flip it over, and then it becomes multiplication. Right?